This is episode 4 of How to Build a Shipping Container House, and we're going to focus on how we installed this above ground septic system. Let's begin with a question that my friend's 7-year-old daughter asked when visiting a construction site. Where does the poop go? This is actually a really important question when designing in rural locations that don't have access to a municipal sewer system. The answer for this house is a little bit different than most. It ends up in these wildflower gardens. When you flush the toilet, run the sink, or take a shower in the house, the water and waste all ends up going into a 3-inch diameter pipe and flows down into a septic tank. I purchased a 1,500-gallon concrete septic tank, and we needed a crane to drop it into the hole that we dug just about 60 feet away from the house. Even though the tank just looks like a big simple block, it actually has a few key features inside that help it separate the waste into 3 different layers. The majority of the volume coming in is water, but as it collects in the tank, it starts to stratify. Grease, oil, and soap bubbles float up to the top to form a layer of scum. Solid waste sinks down to the bottom where it slowly dissolves to form a sludge. In the middle, we have a layer of water that is full of small particles of waste. This is often called effluent. This water is full of bacteria and chemicals like nitrogen and phosphorus, which actually make really good plant fertilizer. So we are going to pump out that effluent and use it to fertilize and water the flower beds. This is important because the 1,500-gallon tank would get filled awfully quick if we didn't remove this large component of wastewater. Using these above-ground concrete planters wasn't our first idea. Originally, we thought we'd do a very conventional septic system where the effluent just drains by gravity into a leach field. But in order to get a leach field system approved by the county, you have to perform a percolation test that demonstrates that the soil on the property can safely handle the effluent. This is done by drilling holes deep into the ground and seeing how fast water disperses in the holes. We tried a bunch of different locations on the property, but we kept hitting rock just about a foot or two beneath the surface. We finally found a location where we didn't immediately hit rock, and it was really cool to see how this giant modular drill bit snaps together so you can keep going deeper and deeper. Soil samples are also collected and sent to a lab for testing to determine their capacity for distributing the water and remediating it. The water test wasn't looking good, and later when we got back the full report from the engineering firm, we learned that due to the poor draining nature of the soil, we would need an area bigger than what we had available for a proper leach field. The guy that we hired to dig the foundation suggested that we over-excavate a large portion of the site and then fill it in with soil to create an area of dirt that drains better. But after half a day of trying to dig through the rock, he was wearing through the teeth on his excavator really quickly, and we realized that it'd be cheaper just to bring in concrete containers. Seeing these nice solid rock walls in the trench though definitely made me think about doing an underground project in the future. So we struck out on the percolation test. The over-excavation plan really wasn't working that well, and so we turned to our friends over at Action Pumping to come up with a above-ground leach field design. In addition to the 1,500-gallon concrete septic tank, we also bought 4 of these 1,000-gallon planters. Knowing that we were going to be going up against a lot of rock, we rented a bigger excavator to dig the hole for the septic tank. The septic company asked us to dig a hole that was 1 foot bigger than the tank all the way around and to put in 6 inches of packed down gravel in the bottom of the hole. This way they'd have a nice flat surface to set the concrete tank down on without worrying about it cracking. We checked to see if it was level, and it was just a little bit off, so we picked it up again and kept pushing a little bit of rock and gravel underneath it until we got it level. I really like this sling or harness that they use to pick up these big concrete tanks. I used a mini excavator to push a pile of dirt closer to start filling in around a septic tank. This was one of my first times using one of these, so I played it a little bit on the cautious side, and then rather than getting too close to the edge, I did a lot of hand shoveling as well. I rented this mini excavator from Home Depot for about $1,000 a week. It only took me about 15 minutes to figure out how to use it, and it came in really handy for digging and filling in the trenches for the drain pipes. For the concrete planters, I'm going to place them all in a row, and I'm just going to dig out a flat surface about 8 inches deep. This way I'll be able to bury the pipes that come out low but on the sides of the planters. Now, I've made a lot of concrete things before, and for a second I thought about making these planters myself, but these ones only cost me about $650 each and saved me a ton of work. On formwork alone, I probably would have spent about $100 for each one. The crane truck only had room to store 2 of the planters, so they had to drive back to the flatbed trailer and load the last 2 planters before placing them. Seeing these large precast concrete objects gave me a lot of ideas for future projects. I think it'd be really cool to make a hot tub out of one of these, or to make a giant above ground garden maze. There are 2 holes in each planter, one to supply the effluent from the septic tank, and the other one is an overflow in case the planters get too full. I dug a trench along the side that has these 2 holes. We then brought in some 2-inch ABS pipe to create an overflow line that, in the rare event if the planters get too flooded, the excess water can then drain back into the septic tank. We then installed a small pump that can send the effluent up a 1-inch polyethylene line and into the planters. We have a volume control valve going into each planter so that we can control the amount of effluent entering each one. Inside the planter, the effluent will come through these PVC pipes and be distributed near the top of the planters. This way it can filter down to the bottom. We poured gravel around the overflow drain pipe and then put a layer of landscaping cloth over that. The vertical black ABS pipe has perforations at the top and will serve as our overflow system. This way, if the planters get flooded, the excess water will flow back into the septic tank. Now, back down by the septic tank, we had to install a dry box so that we can bring electricity down to power the pump. Now, just in case we ever need to increase the capacity of the leach field, we installed an extra outlet that can dispense effluent. We used a submersible pump that is triggered by a floating buoy. So when the effluent level gets too high, it turns on and pumps it to the garden beds. I would have preferred not to use a pump and place the planters downhill from the septic tank, but on the property there's a valley that when it rains channels and drains water, and the building department was worried about contamination from a leach field getting caught up in flash flood waters and being swept onto neighboring properties, and they wouldn't want to be a crappy neighbor. We then buried all the pipes and stacked stones around the volume control valves so that we would have access to them. We're going to need a lot of soil for these planters, so we picked up a trailer full of this really cheap dirt from a local landscaping company. It'll be good for filling up a lot of the volume in the planters, but there isn't a lot of organic nutrients in it. I picked up a pallet of topsoil from Home Depot, which we'll use for just the top layer of the planters. That way we can kickstart a bunch of plants growing and create a healthy ecosystem that'll help remediate the effluent. I used a small skip loader to start dumping the dirt on top of the landscaping cloth. Once the planters were about 3/4 of the way full, I had started getting close to the PVC outlet where the effluent was going to come through. I then laid down a bed of 3/4-inch gravel that's lined on either side by some rocks. I drilled a bunch of holes in a piece of 2-inch ABS and then fit that over the PVC to disperse the effluent. I then added a bunch of topsoil all around it. We put some water in the septic tank to test the system and then opened up the handle on the volume control valve and saw that the system was working. We then placed more gravel and rocks on top of the ABS pipe and our planters were ready for plants. I then threw in a whole bunch of wildflower seeds and it wasn't long before we had a nice lush green flower bed. After about a month of light use, the system seems to be working really well, but that's way too short of a test period to fully endorse a system like this. The biggest advantage of this system is that it gave us a path to approval that didn't require a percolation test. And when you factor in how much those tests cost and the unpredictability of the results, this seemed like a worthwhile experiment. This entire system cost just about $8,000, which really isn't too bad considering how important it is. I will post drawings and specifications for this system on my website. And speaking of drawings, I've had a lot of people asking if they could purchase the complete house plan set for this project. So I put it up for sale on Gumroad and I'll put a link to that in the description box below. That being said, this is going to make a fantastic vacation house, but unless you're going to build it yourself, it's probably going to be about 15 to 20% more expensive than conventional building methods. So please don't buy this if you think it's going to be a miracle solution to your housing problems. If you want to see a lot of the furniture that we're building for the interiors, be sure to go to the Homemade Modern YouTube channel. That's where we show the DIY projects. We recently published videos showing how to make this modern sofa and this combination planter and side table. In the next episode of the Modern Home Project, we're going to go over the electrical and HVAC systems for the house and get it ready to paint. Thanks for watching, and be sure to subscribe to this channel and turn on notifications. That way you'll know exactly when I post the next episode. And lastly, I just want to say I'm sorry for taking so long to get this video out. I haven't put together videos at this scale before, and I way overshot, and there's just so much footage to go through. So everything will get done and published and put up on the website, but please just be patient in the meantime. Thanks. Bye.